Two sounds differ in sound level by 1 decibel. What is the ratio of the greater intensity to the smaller intensity? So what we'll do is we will let I2 be the sound with the greater intensity, and then we'll let I1 equal the sound with the smaller intensity. And so in effect, we're looking for the ratio I2 over I1. That's our big question right now. And we're going to be able to do that because we know that the sound level, which is symbolized by beta, is equal to 10 decibels multiplied by the logarithm of the sound intensity divided by some reference intensity level. We also know in the question that two sounds differ in sound level by 1 decimal. Let's take that statement highlighted in yellow and just sort of translate it. So what they're saying is that beta 2 minus beta 1 would equal 1 decibel. But we can fill in some useful expressions for beta 2 and for beta 1 because of the sound level equation. So for example, for beta 2, following this equation right here, we would have 10 decibels multiplied by the log of I2 divided by I not that reference intensity. And then we're going to subtract beta 1. We'll set up a similar expression. And then this, of course, again, is all set equal to 1 decibel. So the big question is, how do we solve this for I2 over I1? Well, the first thing we might do is factor out the 10 decibels. And then after factoring out the 10 decibels, we can divide both sides of the equation by 10 decibels, canceling it on the left-hand side. And on the right-hand side, it looks like we're going to get 1/10 or 0.1. Now we're going to use a logarithm property to simplify the left-hand side. Now, many of us have learned in a mathematics course that if you have the logarithm of A subtracted by the logarithm of a quantity B, we can rewrite that as a sort of ratio. It would be the logarithm of A divided by B. So using that property, we can take the left-hand side and rewrite it according to the following. We would have the logarithm, and then the sort of A that we were representing earlier would be this quantity, so we'll put that in the numerator. We'll have I2 divided by I naught, and then that's going to be divided by B, which is this quantity right here, so we'll have I1 over I naught. And again, this is all equal to 0.1. Now we can algebraically simplify inside the brackets there because the I naughts would actually cancel out. And then to finally solve for the ratio, what we do to get rid of this logarithm is we raise 10 to both sides of the equation. And 10 to the log, those are inverse operations. They cancel each other out. We are left with I2 over I1 is equal to 10 to the power of 0.1. You can certainly enter that into your calculator. And when you do so, you get the ratio of I2 to I1 approximately equaling 1.26. So this indeed is the correct answer to the question.